Hello my schoolers, you're welcome to my school YouTube channel. My name is Emmanuel and today we'll be looking at topics by topic video lessons in chemistry. Please don't go anywhere, stick around and we'll be right back. Welcome back to my school YouTube channel. Like I said earlier on, today we'll be looking at topics by topics video lessons in chemistry. Now let's get down into it. The first topic we'll be talking about is separation of mixtures and purification of chemical substances. Underneath this, we'll be looking at what the definition of matter is. We'll be looking at different classes of matter. Also, we'll be looking at elements, compounds, and mixtures. We'll look at substances that can be classified as compounds or as mixtures. We also try to look at the differences between compounds and mixtures. And we'll be looking also at pure and impure substances. What are the criteria? What are the factors that determines the purity of a particular substance? We look at melting point, we look at boiling point, and we look at things that can make a substance to be classified as a pure substance or an impure substance. Also, we'll be looking at the different separation techniques. How are we able to separate mixtures into their different components? There are different techniques and processes we'll look at. We'll look at the simplest of them, that can be decantation. We'll look at filtration, we'll be looking at crystallization, we'll look at fractional crystallization, we'll be looking at distillation, we'll be looking at fractional distillation, we'll be looking at magnetization, we'll be looking at chromatography, and so on and so forth. We have as many of them that we'll be looking into. Then away from that, we'll look at the second topic, which is chemical combination. Chemical combination, underneath that, we'll be considering stoichiometry. Stoichiometry is just a terminology that has to do with the way compounds react with each other, elements react with each other to form another substance, to form a new substance. That is what stoichiometry is. So we look at how we are able to balance the equation. That's another word for it. We balance the equation of different components that make up that particular compound. We'll be looking at that. Also, under the chemical combination, there are laws that help us to guide us in combination of compounds. We'll be looking at the law of conservation of matter or law of conservation of mass, as the case may be. We'll be looking at the law of definite proportion. We'll be looking at the law of multiple proportion. We'll be looking at relative atomic mass. We'll be looking at atomic number. We'll be looking at a lot of things that will make up the chemical combination to eventually take place. Then away from that, we will be looking at kinetic theory of matter and gas laws. Underneath that, we'll be looking at some assumptions that are given by some scientists about the behavior of gases. Looking at assumptions, things that make gases behave the way they do. We'll be looking at that. Pressure could be one of the factors. Temperature could be one of the factors. The volume of that gas could also help to determine the way the gases behave. We'll be looking at that. And of course, there are some laws that were given by those scientists. We talk about Boyle. Boyle is a scientist. That's why we have the Boyle's law. One of the scientists again is Charles. That's why we have the Charles law. We talk about Gay-Lussac's law. We'll be talking about Graham's law of diffusion. We'll be talking about Avogadro's law, and so on and so forth. That's underneath the kinetic theory of matter and gas laws. Also, we'll be looking at atomic structure and bonding. We'll be looking at the electronic configuration of elements, different elements. You'll be looking at the components that make up the atom of an element. In other words, some people call it particulate nature of matter. We'll look at that. We'll be looking at how those elements are able to combine together. What are the components that make up each element? That is what we'll be looking at. Then we'll look at how we can represent them in diagram, diagrammatic representation of the way the different particulate nature, how they are positioned in the atom of an element. That and more we'll be looking at underneath the atomic structure and bonding, and how the elements are able to bond together to form compounds. It could be by change of their valencies in order to combine together to form compounds. Away from that, we'll be looking also into nuclear chemistry. Nuclear chemistry will be dealing with radioactivity, how different elements are able to disintegrate and break down into forming of new elements entirely. Maybe with number of years, with number of times they have been able to stay, it can help us to determine that. We look at the different types of radioactivity. We look at some little calculations underneath that to help us understand how you can calculate. Do you know that someone that has died 20 years ago or 100 years ago, we can be able to determine how long it has taken for that decomposition, decay to actually take place? We'll be looking at that under the nuclear chemistry. Also, we'll be considering air. Air, like you know, the basic science that air is a mixture of gases. Okay, so there are a lot of gases, different gases make up air. So we'll be looking at the different components that make up air as a mixture. We'll be looking at noble gases, we'll be looking at oxygen, we'll be looking at nitrogen, and the likes of them present in air. We'll be looking at water. Water is a very important topic and interesting topic that we'll talk about because we all make use of water. And then as a scientist, as a science student, you should know what the component of water is. You should be able to also tell us the different types of water that we have. Is it hard water? Is it soft water? We will look at that. Then we also look at the compounds that actually make water what they are. We look at how we can be able to purify water and make it fit for consumption, for human consumption. The water you have around, how are we able to make it, to treat it, the kind of treatment we can give to it to make it fit for human consumption. Then we'll be looking at solubility. Solubility, underneath that, we'll be looking at what solutions are, what make up solutions, solvent. We'll talk about solvent. We look at different solutes that make up solutions. Then we'll be looking at the different types of solutions that we have, be it true solution, be it false solutions, in terms of colloids and the likes. We'll be looking at saturated solution, we'll be looking at unsaturated solution, we'll be looking at super saturated solution. All of those ones we'll be looking at under. Then under it also we will do some calculations to be able to determine the solubility levels of different salts, of different compounds when they are dissolved in their respective solids. Of course, like you know, water is a universal solvent. We'll be looking at that also. Away from that, we'll be looking at environmental pollution. What are the things that constitute a polluted environment? We'll talk about the different types of pollution, talking about air pollution, talking about water pollution, talking about land pollution or soil pollution, as some may say. So we look at the different component pollutants that we can have in such environments and what we can do about reducing the level of pollution in our environment. Also, we'll be looking at acids, bases, and salts. This is a very interesting topic you cannot wait to have a look into. Acid, bases, and salts. We look at what acids are, definition of what acids are. We look at the different types of acids that we have, talking about their classes, talking about organic and inorganic acids. We look at what acids, where can we find acids, what are the sources of acids. Even in the food that we eat, we have some acids. Even in our body, we have some acids there. Okay, so all of those ones we'll be looking at under acids. Also, we'll look at what bases are. What are the properties of bases? Just like we'll look at that in acids too. What are the characteristics of a substance regarded as bases? What are the physical properties, chemical properties of bases? And how do we identify them when we see them? Then we look at salts also. What are salts? Well, to a layman, salt can just be what is used in the kitchen. That mommy used them, we cook, and so on and so forth. But to a scientist, to a chemist, it It is much more than that. Well, that is just part of it. So by the time we look at what salts are, you will know that there are different types of salt that we could have. We talk of normal salt, like the one we use at home. We talk of acidic salt. We talk of basic salt. We talk of double salt. We talk of complex salt. Then we look at the different types of salts that we have, like I said earlier on. We'll then look at the different ways we can conserve the salts. We talk about hygroscopic, we talk about efflorescence, we talk about delinquencies. So, and the type of salts that behave the way they behave. There are some salts that when you expose them, they absorb moisture and then they turn into solution. There are some salts that when you expose them, they absorb moisture, they don't turn into solution, but they just become sticky. You know, there are some salts that, in fact, when you expose them, they lose the moisture that is present in them. So also we'll be looking at water of crystallization. The amount of water that is present, the moisture content that is present in that particular salt. All of those ones we'll be looking at under salt. Then remember, we also, while talking about acid, we'll be talking about pH, we'll talk about pOH scale also, and then we'll look at what the acid-base titration is all about. The reaction between acids and base, which is neutralization reaction to give us salt and water. Now let's move on to the next slide. The other topic we'll be looking at is oxidation and reduction reactions. Some people refer to it as redox reaction. Redox, red for reduction, and then the ox for oxidation. So oxidation reaction, we'll be looking at different definitions of oxidation. Some say addition of oxygen, some say addition or removal of hydrogen. We'll look at all of those ones in that. Then underneath that also, we'll be looking at different reactions. The different reactions we can refer to as oxidation, or reactions that we can refer to as reduction. We'll be looking at what we call oxidizing agents. We'll look at what is reducing agent. Then we'll be looking at the different oxidants and different reductants. We'll be looking at the different oxidation number. How can we determine the oxidation state of a particular compound? We'll be calculating. We look at some rules that guide us in determining or calculating the oxidation number of certain elements in different compounds or radicals. When we talk about radicals, we're just talking about a group of atoms that are combined together, chemically combined together, and then they are charged. You can have SO2, SO42 minus can be a radical, Cl minus can be a radical, and so on and so forth. Away from that, we'll be looking at electrolysis. Underneath this electrolysis, we'll be looking at what are electrolytes. We'll be looking at what are cathodes. We'll be looking at different types of electrode. We'll be looking at salt bridge. We'll look at the laws of electrolysis. According to Faraday, we have Faraday's first law of electrolysis, second law of electrolysis. Then we'll do some calculations under that. And then we also look at what are the uses of electrolysis. Where do we find applications in our day-to-day life? In purification of metals, in electroplating of metals, and so on and so forth. And then lastly, underneath that, we'll be looking at compounds we can refer to as electrolytes and the likes of them underneath electrolysis. Now the next topic we'll be looking at is energy changes. Underneath that, we'll be looking at energy changes that accompany physical and chemical reactions. We'll be looking at the different types of reactions we have, talking about exothermic reaction and endothermic reaction. We'll be looking at the reaction curve as well. When we have exothermic and endothermic reaction, how does the curve, how does it look like? We'll be looking at that. Then we'll be looking at entropy. Entropy has to do with the level of disorderliness, okay, in a system. We'll be looking at that underneath the energy changes that we have there. Away from that, we look at the next topic, which is rates of chemical reaction. Underneath that, we'll be looking at what the definition of rate of chemical reaction is. How do we define the rate of chemical reaction? What are the ways by which we can measure the rate of chemical reaction? And then we also look at some calculations underneath that, just a light one anyway. We'll be looking at the different theories. We talk about collision theory. We'll be talking about the Arrhenius law underneath the rate of chemical reaction. Then we'll be looking at chemical equilibrium also. Chemical equilibrium, we look at what the definition of system is. We look at what the definition of a surrounding is. We look at what a dynamic equilibrium is. We look at different examples of equilibrium solutions, equilibrium reactions that we can have. Then we'll be looking at factors that can actually affect the chemical equilibrium. Factors such as changes in temperature, changes in volume or concentration of the reacting species. Then we'll be looking at the effect of pressure. We'll be looking at the effect of catalyst. How do catalysts have any effect in chemical reaction, or do they not? When we have a specific kind of catalyst, we'll be looking at the effect of increase or decrease in concentration of any reacting species at all. Does it have any effect on chemical reactions? We'll be looking at that. Then we'll be considering also what happens when the temperature increases. Does it have any effect on the chemical reaction? If the pressure is increased or decreased, does it have any effect? We'll look at that. All those ones actually were brought about by the scientist called Chatelier, and then we refer to it as Le Chatelier's principle. The Le Chatelier's principle will be looking at what it entails and the application in chemical equilibrium. All of those ones we'll be looking at underneath the chemical equilibrium. Now we look at the other topic we have is non-metals and their compounds. Non-metals and their compounds. We'll be looking at different elements that are non-metals. We talk about oxygen and their compounds. We talk about nitrogen. We'll be talking about halogens. One of the examples of halogens, of course, we know that they are the group 7 elements, okay? So we have chlorine. We'll be looking at that because of its importance. So all of those elements we'll be looking at, those metals, non-metals we'll be looking at, we'll see how we can produce them. We call it laboratory preparation or industrial preparation in large quantity. So we look at them, each of them one after the other. We look at their properties. How can we test for their presence where we have them? So we'll be looking at all of those ones, and then the reactions that they can take part in. Physical, chemical reactions. How are they able to react with one another, with another non-metal, or react with a metal? What kind of reactions can they undergo? We also look at metals and their compounds. Metals and their compounds, we look at the general properties of metals. How do they behave? Do they have high melting point and high boiling point? Do they have ductility? Do they conduct heat and electricity? We'll be looking at the different properties of metals. And all the metals we'll be looking at different ones. Of course, we cannot exhaust them because we have a whole lot of them. So, but we have those ones that are special, like the aluminium. We'll be talking about aluminium. We talk about iron. Then we also talk about the transition metals. Transition metals are a special type of metals. We will talk about them. We look at the characteristics that they have. We look at the features they have. What make them special? What make them outstanding from other types of metals? For instance, we talk about their ability to behave as catalysts. That's one of the characteristics. Some of them are used as catalysts to speed up the rate of chemical reaction. We'll be looking at that. We'll be looking at the oxidation state. Some of them are variable oxidation states. Oxidation number, like you have, if it is like calcium has an oxidation state of +2. Okay, it has a valency of +2. It doesn't have a variation in the oxidation state. But when you look at transition metals, transition elements, you can have a metal that has about 3-4 different types of oxidation numbers and then ascribe to it. They also have color formation and the last of them. So we'll look at all of those ones when we're treating or talking about metals and their compounds. How are they extracted? In their raw state, some of them, how are they able to form alloys, combining with another element to form a desirable substance that we have? Just like we have the bronze, you have about three different elements combined together to form bronzes. So we have them like that. We'll be looking at the likes of them. So we look at also organic compounds. We look at how we come about organic compounds. What substances are referred to organic compounds? Of course, it's broad anyway. We'll be looking at the different types of homologous series that we have. We'll be looking at the alkane, we'll be looking at alkenes, we'll be looking at alkynes. We'll be looking at different reactions that they can undergo. We'll be looking at the saturated and the unsaturated compounds, hydrocarbons. the alkanes and alkynes. How can we distinguish them from each other? How do we test? How do we distinguish? If we have the 3 hydrocarbons, talking about alkane, alkene, and alkyne, if you have the 3 of them, maybe each of them in a setup, okay, maybe they are all colorless, substances. How do you identify which is alkane? How do you identify which is alkene? How do we identify which one is? There are tests that we'll carry out. So we'll be looking at that underneath that. We'll be looking at alkanols, very important. In the brewery industries, alkanols find the application. Fermentation reaction, we'll be looking at that. How do we have it? Do you know that you can even produce palm wine in the comfort of your homes? Stay back, we are going to talk about that when we get underneath that organic compounds. We'll be looking at esterification process. We'll be looking at alkanoic acid. We'll be looking at alkanoids, or what's called carboxylic. They have a carboxylic group. We'll be looking at alkanals, and we'll be looking at alkanones. 2 of them, they look alike, because when you look at the structures, they look alike. We'll be looking at their general formulas. We'll be looking at differences between alkanones and alkanals. What separates them? What distinguishes them from each other? There are tests that will run to show us that. We'll be looking at fatty acids. We'll be looking at proteins, that's lipids, underneath that. And then we'll be looking at soap and detergents. All of those ones we'll be talking about under the organic compounds. The last topic we'll be looking at is chemistry and industry. Underneath that, we'll be looking at the different types of chemical industries that we have. We'll be looking at the different types of chemicals that we have. We have fine chemicals, we have heavy chemicals. We look at the different chemicals that can be grouped and classified under each of those. We have sodium hydroxide, where does it fall in? We'll look at that. We have H2SO4, where does it fall in? We'll look at that. We have sodium hydroxide, which is caustic soda. We have sodium chloride, of course, your salt. Do you know your salt is also a chemical? Where does it fall? So we'll be looking at all of those ones. Then we'll be looking also at the economic importance of having chemical industries in a nation. What do they contribute to the growth of a nation? This and many more we'll be considering under this topic, chemistry and industry. Now we have come to the end of this video lesson. If you want to have access to the full video of this topic by topics in chemistry, please click on the link in the description below, which takes you to the My School website where you have access to subscribe. Please subscribe. I believe you have enjoyed this content. If yes, please do not forget to click the like button, tap the subscribe button, and lastly, hit the notification bell to get you informed once we upload our next video.